So let's get started. We only have an hour and we have 84 slides. So be prepared. So welcome to our talk from Zero to Kubernetes. We did a similar talk at GPN in spring, and we decided to do another round of this, this time in English. So I know the CFP was written in German because we were too lazy to translate it in time. So I'm sorry. I hope English is fine for everyone. Yeah, we prepared some slides about Kubernetes, when to use, when not to use, and all right, Heiko.
Yeah, one small warning. We're not only talking about the open source part of Kubernetes, but also some closed source and proprietary products, which we have to mention because they're also part of the ecosystem. But yeah, let's get started.
If the clicker works.
A bit about me. I'm a senior consultant from Reply. I work mainly with AWS, putting electric vehicles in the cloud. I'm also doing event photography. You might see me here at FrostCon as one of the social media persons who takes pictures for FrostCon on Mastodon. And during my free time, I also ride my longboard because I prefer it to transportation via car or other public transport.
Right, and a little bit about me. I'm a senior software engineer at Microsoft. I work on Azure, and I'm primarily breaking things in production, so I'm doing chaos engineering. Kind of fun, but also kind of tough to do. And obviously, I do work a lot with Kubernetes. Like Heiko, I enjoy a lot of time doing photography, but I don't have a camera with me, so you won't see me taking pictures. And yeah, I'm practicing Brazilian Jiu-Jitsu for the past 2 years now. So yeah, getting some physical exercise is kind of nice after mutilating servers all day. Right, before we jump into Kubernetes as an orchestrator, I think we should first talk about containers and VMs first, so you have kind of a basic understanding. So quite some time ago, we figured out running stuff on physical servers is pretty impractical for various reasons. Managing VMs is a lot easier than managing hardware, but as you can see from the stack here on your right, there's quite a few layers to it. You have your server, you run an operating system on the server, usually Linux, and then you virtualize an entire new Linux on top of it. So it multiplies the amount of Linux servers you have to administrate just to run like one application for each VM. That's not the perfect resource allocation. It takes quite some resources. It takes some additional work patching every VM, and not really optimal. That's why some very intelligent people came up with the concept of containers, where you basically package a virtual machine in a container, but without actually executing that VM. So it only provides the libraries necessary to run an application, and it's much nicer, much less overhead, much easier to deploy. Obviously, there's pros and cons to both approaches. The pro of having containers is it's pretty consistent. You can do Docker up on each machine. It's the same everywhere. It's not like you have to manage a VMware on one side and the Proxmox on the other side. You can pretty easy automate it because the CLI is pretty standard, and running containers works the same everywhere. It's pretty easy to actually automate the deployment of Docker containers. Same for stability, reliability. It's just, if a container dies, you can just restart it because it's not an entire virtual machine that needs to be rebooted. It's just the application that needs to be restarted, which is usually a lot faster.
Yeah, but it also comes with some downsides. You have yet another layer. Most times that layer is configured with YAML, which you might like or don't like. You have a rather steep learning curve on how to containerize your applications. You really need to depend on proper documentation, and you have a plethora of tools that all work differently, and you have to choose what's right for you, or as with me, I have to learn the tools that our customer uses. So there's always a learning curve involved, and yeah, in the end, it's sometimes not that standardized as you would hope. So yeah, here we see the different VM orchestrations, like libvirt, like KVM. And of course, you can manage VMs, but in the end, if you want to have a scale application, then it gets troublesome, and most of the times you need some proprietary, costly software to do large-scale VM orchestration, and that's why we come to the container orchestration.
Right, just as Heiko said, sure, you can manage VMs on a hypervisor using KVM natively, works, but kind of troublesome, so you want to have some orchestrator for it, right? You don't want to log into each hypervisor and manually start and configure VMs. You want to do it from a central place, so you more often than not choose an orchestrator framework like Proxmox or VMware. And it's pretty similar in Docker, in the Docker world. Sure, you can log into each server individually and start your Docker containers, but more often than not, you want to do it programmatically and from a central location. And this is where tools like Docker Compose come into play. Docker Compose, we're going to talk about it in a sec. It's a pretty amazing tool. It lets you spin up multiple Docker containers on a VM, super easy. But sometimes you want to scale to more than just one VM or one server. You want to go and deploy your containers to a bunch of servers at once. And that's when you need orchestrator software, just like with VMs. So if you can manage VMs on one hypervisor manually, sure. But if you want to scale it to a lot of servers, you probably want to use some sort of orchestrator. And this is where we're going to talk about orchestration, and specifically Docker Compose. And I found this really nice quote on the internet from the Docker Compose documentation. It basically says, Docker Compose is a tool for defining and running multi-container Docker applications, and you can do so by defining one YAML file, and that's your entire application definition. You can copy that YAML file to each VM that you want to run on, and then hit Docker Compose up, and you're done. That's pretty nice. Kind of looks like this. This is from the GitLab, I think, right?
Yeah, this was the actual Docker Compose that runs my private GitLab with also Docker registry and everything.
And you can see you define all your environment variables in the Docker Compose, so it's kind of nice to store your configuration alongside your application. Again, there's certain pros and cons to Docker Compose. On the pro side, certainly, it's easy. It's actually pretty reliable. You can select your application restart type, so what should happen if the container dies for some reason. It's, as I said, pretty reliable for that reason. But there's also the con, and that's a pretty major one, actually.
Yeah, Docker Compose is more or less only for single host deployments. So you have to deploy your whole infrastructure on one virtual machine or one bare metal server or one cloud instance, but not multiple times. So Docker Compose doesn't scale that well.
Yeah, it scales to one server. But there's cloud.
And there's a lot of cloud. Every major, and looking at Magenta Cloud, also somewhat minor cloud vendors have their own container orchestration suites and also their own Kubernetes flavors.
You certainly can use them. There's absolutely nothing wrong with them, but they come with their own sort of problems. You have to pretty heavily depend on the APIs that your cloud provider offers you to deploy your Docker container. So while it's probably a good choice for most people, it might be a limitation for some.
Especially if you're doing multi-cloud, you have to adapt to each and every single API, because the API from Azure is vastly different from the AWS API, for instance.
Right. There are many container orchestration tools, and we can't talk about every one of them, so we compiled a list of honorable mentions. Yeah, but we opted to not talk about them for some reasons.
Yeah, for instance, Apache Mesos is dead.
Was
Docker,
nice, but dead.
Docker Swarm, yeah, okay, it's not bad, it's also not great, it's somewhere in the middle. Then we have Service Fabric, which is good for applications where you want to store your state, which you don't really want to do in Kubernetes, but with Service Fabric you can do it very well. Then there is Nomad, which is kind of expensive. Then there's Pacemaker, which for what you really have to build everything for your orchestration yourself, so kind of maintenance heavy. And there's Truna Scale, which I'm sorry I have to say this, but the community is really problematic at some points, especially when you go to True Charts, for instance, where I had as paying customer some support requests and was just sent to Discord, here, please ask your question on Discord. And when asking the question on Discord, I was told, yep, don't ask us questions that we already have solved. Look into our Discord archive for already solved support tickets. We're not going to answer you again a question that was stated half a year ago.
So yeah, you see there's many tools, some of them have problems, some of them are just dead, unfortunately. This brings us to Kubernetes, why we are actually here today. But there's a little spoiler, Kubernetes is not a single tool. I see this so many times that people say, yeah, Kubernetes, but no one really knows what Kubernetes is because it's actually not a single tool. There's this amazing chart. All of this is Kubernetes. Oh, yeah, I go to the side.
If you want to see the full chart, the QR code should be working.
But it's probably not readable. You can go to the Cloud Native Computing landscape and you find this chart. So looking at this chart, it's kind of confusing. So what is Kubernetes actually? And Kubernetes is defined as a set of principles and APIs on how to manage a cluster. It's not really a single tool, a single binary that does the thing for you, but it's rather an API layer. It gives you the right abstraction to do whatever you want. And this is where this picture comes in, because you see it's kind of grouped in several categories. So you basically go and pick the right tool for your job, and then you can basically just drop in that tool in your Kubernetes stack and be fine with it. So if you want to use some fancy networking, you can choose Cilium CNI for a networking operator, or if you would need blob storage, you can use the S3 bucket, MinIO for S3 buckets in Kubernetes. So it's all just plug and play, and all of these tools implement the various levels of the Kubernetes API layer.
So a bit about the basic Kubernetes architecture. You have your master node, which contains the API server, the etcd, which stores most of the configuration. You have your scheduler. If you're in the cloud, you also have your cloud controller manager and the kube controller manager. And then you have multiple hosts that are configured as nodes, where your kubelet is running, where your kube proxy is running, and the pods where your container in the end runs. And everything is more or less controlled by the Kubernetes master, which checks, that pod goes onto that pod goes on another node, so that you have load more or less evenly distributed on your whole cluster.
Right, and there's another misconception about Kubernetes that is pretty strong. Kubernetes is sold as like this distributed thingy where you can run software distributed. But if you actually look at this architecture, Kubernetes itself is not really distributed. You have your master nodes where all the state is kept and all the configuration is done. But it's actually quite central. It's not really distributed, so that might be a downside for some use cases.
But yeah, what's distributed is who also made a Kubernetes distribution. From the left to the right, we go more and more professional and more, yeah, you could say expensive. Being the bottom right solution, of course, being IBM Cloud. And yeah, we in this talk, we want to show you the 3 different stages of Kubernetes clusters, from development to single node and edge clusters, up to our production clusters. And also, we briefly want to talk about the enterprise and cloud clusters. For enterprise solutions, for instance, you have OpenShift, you have the SAP Kubernetes implementation, and for the cloud, of course, you have Google Kubernetes Engine, you have AKS, you have AWS Managed Kubernetes, OpenShift on the IBM Cloud. So if you want to choose, you basically can choose any option you want and have a more or less accessible Kubernetes cluster for you and your workloads.
Yeah, so the goal is basically to show you, like, there are a bunch of different Kubernetes distributions, and it's kind of confusing on when to use which, and this should give you like a starting point on where to look in your journey. But before we jump into the details of when we get, how do we get started on Kubernetes, I think we should talk about when, because there's like this common misconception where people say, yeah, let's just throw things at Kubernetes, it will scale, right? So we prepared a little game just to have some fun, to not be too serious. Let's just raise hands if you think it's a good use case for Kubernetes. First one is serving static content. Is this a good use case? Good use case? No, not really actually. If you want to do static content, just use an S3 bucket. Like, you have S3. Just use it. It's much cheaper and much easier to use. If the content is not changing, you can just upload your files to the bucket and be gone with it.
Also, it's much greener to use just static file storage and maybe a CDN, because you don't waste CPU cycles on orchestration or anything.
So another big one, another controversial one, should we host databases on Kubernetes? I'm going to go quick and say, no, please don't. There's an amazing tool for that. It's called Service Fabric by Microsoft. It's open source, don't worry. I'm not paid to say this, but it's actually quite good. But actually, your head's going to explode. It's the ramp-up time for Service Fabric is hard. You're going to have a really hard time getting started on Service Fabric, but it's amazing for stateful workloads, and it's actually the technology that most stateful storage on Azure is built on top of. Another fun one thrown in the mix: should we do physical safety systems in Kubernetes? Fuck no. Use like proper SCADA systems for it. Yeah, I mean, if I have like a 50-ton press that does some pressing for the automobile industry, I don't want to make my life dependent on a Kubernetes cluster. I really don't. I don't want to reach into a press and then have 50 tons above my head and I have to fear, is the pod running or is it crashing? I don't know. Use SCADA.
Did we reach the Docker Hub limits again?
Yeah. So now a fun one. We briefly touched on it for stateful workload. I mean, we kind of touched on it for databases. But in general, like stateful workload, what do you think? Good or bad? Yay or nay? I see nay. It actually depends. It's certainly not the right use case if you store your state inside of the cluster. Like if you need to store state on a file system, for example, Kubernetes is really not the best choice for it. You can do it, but it's not the best choice.
But when you can separate your application and your state and store the state, for instance, in an S3 bucket or on a network file system, or in a database cluster that is not on your not in your Kubernetes cluster, but some managed database servers or something, then Kubernetes might be a good idea for your stateful applications. So, quick show of hands: who thinks your company's legacy or enterprise Java application belongs in a Kubernetes cluster?
I see a lot of nay. Very enthusiastic nay.
Well, actually, maybe. There are some pros and some cons. With Kubernetes, you might be able to improve the density in comparison to running your application once on a single host. You might be able to run it multiple times on that single host and have a bit of separation between the applications. Also, especially if you're working with Java applications, you don't have JVM dependency problems because each pod should bring their own JVM. And if you want to run multiple applications on the same physical machine, you don't have the dependency problem that one application needs JVM version X and the other one needs JVM version Y. They both bring their own ones with them. And also, yeah, state is properly or hopefully stored somewhere else. So your application might be working well on a Kubernetes cluster.
I'm just thinking about like the stereotypical enterprise application that stores its data in an AS400 database or something. Does exist, so well, maybe. But there's some cons to it as well. If you use Kubernetes, it will not magically make your application scale. Yeah, Kubernetes can do auto-scaling, but that doesn't help you if your application can't handle it. If your application is not designed to do horizontal scaling, then Kubernetes won't magically make your application scale. And if you use like enterprise Java software on Kubernetes that's not made for Kubernetes, it just won't use any of the Kubernetes benefits. You will just be using Kubernetes for the orchestration, but you get the hard parts, but none of the nice parts. So yeah, some cons there as well.
So Kubernetes for edge computing? Anyone who thinks that's a good idea? Yeah, a few people think that's a good idea. Actually, it's also kind of a maybe. You run your services in a very standardized way and have the opportunity to run it close to the customer. You can also distribute, sync your applications. And yeah, as I mentioned earlier, state should not be in the cluster. It is hopefully stored somewhere centrally. So all applications get their state from the same source.
So yeah, it's you see, it's like the typical answer of a senior engineer. It depends. So there's no clear yes and no most of the time. It really depends. So again, cons. Yeah, it's probably a good idea, but managing multiple Kubernetes clusters can be quite hard because you need to roll out changes across many clusters at the same time in sort of a standardized, orchestrated way. So it's sometimes a bit harder to do. And also, if you have multiple clusters spread around the world, you might run into some latency issues between the clusters, which you might want to avoid. But that should be an easy one, hopefully.
Yeah. Who thinks Kubernetes is right for your stateless microservices?
Yay!
Yeah, a lot of hands there, yes.
And last but not least.
And at the last point, yeah. Who thinks Kubernetes is the right tool for serverless computing? A lot less hands. Again, yes, it is a good idea, but also it depends, and you might need additional software like OpenFaaS or
Knative.
Yeah, Knative.
So yeah, another quote that I found on the internet that sums it up pretty well. Only default to Kubernetes when there's no better alternative available to you. So it might be a good choice, but carefully evaluate if there might be a better option for you. Most of the time, there is actually a better a better option instead of using Kubernetes. So again, to evaluate if Kubernetes is really the right tool, carefully evaluate your actual infrastructure requirements. Don't build your requirements in a way that it enforces Kubernetes. Be open-minded about the technology. Maybe like a cloud provider, platform as a service is the right tool for you, but actually evaluate your functional requirements and do it carefully and properly. One thing that I want to mention specifically, because it's overlooked a lot of times, is the last point on the slide. Do you actually have the capacity to run a Kubernetes cluster? It's not like you just do magic command and there's a Kubernetes cluster and then everything magically happens. It's actually quite a lot of work to run and operate a cluster. So be sure you have that operational capacity. And as I said, evaluate your alternatives. There are some great ones available. Like maybe you just need a VM and go to Hetzner and be fine with it. Maybe there's no need for Kubernetes, right? Maybe function as a service is the right thing for you, and there's plenty of those available. So just go out and explore the possibilities. And don't fix your mindset on, yeah, I have to use Kubernetes. Nice.
So after we more or less scared you away from Kubernetes, we now want to show you how to start with Kubernetes, get your first development cluster up and running, and yeah. Again, we have the 3 different types of distributions here. We have the development distributions, we have the single node and edge, and the production clusters. And for development, Sid is going to talk about kind.
Yeah, it's actually my favorite one, and I use it all the time. It runs on your VM, on your developer machine, on your laptop, on your MacBook, whatever. And it's as easy as typing kind create cluster, give it a name, and be done with it. And you have a fully functional Kubernetes cluster that is running on your developer machine. So it's the perfect way to get started, the perfect way to get yourself familiarized with Kubernetes without paying for a VM, without sacrificing another Raspberry Pi, because they're kind of rare nowadays. You can get started pretty easily, and I don't see many people using this, and I really encourage, especially application developers, if you need to test your Kubernetes application before pushing it to a testing infrastructure, maybe just deploy it to a kind cluster. It's super easy to get started, and you can see it from the screenshot. It takes literally 15 seconds of your time. So beat that.
Yeah, then if you want to go the next step for a single node, edge, or home lab deployment, my choice would be K3s on a single node. That's also what I'm currently using at home in my home lab. Benefit of K3s is you can then later expand on, to a multi-node cluster. You can even mix your cluster with having an x86 worker and a Raspberry Pi in the same cluster. Your scheduler will take care that ARM applications will run on the Raspberry Pi and x86 applications will be running on your x86 machine. But please create a systemd service that keeps K3s running after reboot. Otherwise, your applications won't come up because nobody told your underlying Linux, hey, we need that cluster again. And please use the K3s Ansible playbook, since there's already great work that some people have done to easier deployment. So you don't need to reinvent the wheel.
Yeah. The K3s Ansible playbook is really good, especially if you're setting up multi-node clusters. Really, really good. And the last step, if you want to go all the way, and I mean, not all the way. If you want to do enterprise Kubernetes or cloud-based Kubernetes, you're on your own. I can't help you. But if you want to build your own production-ready Kubernetes cluster, whatever that means, and you want to do it properly, use tools like the Cluster API. It's pretty neat. If you're familiarizing yourself with Kubernetes, everything is declarative, right? You have YAML files for everything. All your configuration is stored in a YAML file. Cluster API takes that to the next level, and it lets you define your Kubernetes cluster in a YAML file. I mean, yeah, I'm joking all the time that I'm a YAML engineer, but it's kind of nice if you have your cluster definition in YAML. If you want to do a cluster update from, let's say, 1.18 to 1.19, just update the version string in your YAML file, apply it, be done with it. It's really good. It's not going to be easy. There's a lot of hassle with that, but we warned you, be careful. And now that we have in cluster, let's deploy some workload on it. As I said earlier, you want to deploy Docker containers, right? You want to orchestrate Docker containers on multiple machines. In Kubernetes, we don't actually manage individual Docker containers for various reasons. What we actually manage is a pod, and a pod can be one or more Docker containers. I don't want to get into the details here, but generally we can say one pod is one application container and don't care about the rest. And we certainly can deploy an individual pod, but most of the time we want to use a deployment, because the deployment then in turn deploys a replica set, and the replica set allows us to scale. The replica set is what makes the Kubernetes pod scale so easily, because you just say replica count 5 and you have 5 pods running. You scale down by setting it back to 2 and you have only 2 pods left running. And this applies to a lot of concepts, so there are a lot of high-level deployment types, and I certainly don't want to dive into each and every one of them. Just be aware there are like 3 more major types. It's jobs for jobs. It's daemon sets. They're kind of nice because it allows you to run exactly one container or one pod on each of your nodes. So if you're adding a new node, then this pod will be deployed on that node automatically. Super useful for stuff like monitoring. And the last one, I really don't want to get into the details. There are stateful sets that are kind of designed for stateful workload, but they're sort of magic. If you want to know more about it, read the Kubernetes documentation. And since we don't want to write YAML files all day and specify every single parameter, there are some great tools like Helm or Customize that allow us to reuse existing configuration and just modify the parts that we're interested in modifying. And Helm is, especially since Helm v3, it's a great package manager. It's similar to apt on Ubuntu and RPM on SUSE-based distributions. You install a package, install an application, but it also packages the configuration with it. So you install a package and you configure it all in the same step with Helm. That's kind of nice. Tanka is a new one on the block. Let's see how it will go. And last word of caution, don't run kubectl apply -f on production clusters. I know, you have to get your configuration on a production cluster, right? But if you run kubectl apply from your developer workstation, you never know what's actually applied to the Kubernetes cluster. You might have one developer doing this on his machine and another developer 10 minutes later doing something else, and then the first developer's like, man, where's my configuration that I just deployed? And it's kind of sucks. So yeah, don't deploy anything manually. There are reasons for it. And we solved this using a process called GitOps. And I mean, we do this for years. It's just, we had to coin this term for Kubernetes specifically. And yeah, Heiko.
Yeah, with GitOps, you have your continuous integration workflow as you know it. You develop in your IDE. You build it, check it into Git, you test it, you develop it again because your deployment contained errors. And Git is the magic tool that connects your Git repository with the Kubernetes cluster. So your workload gets automatically pulled, deployed, if you have good monitoring in your cluster, it gets also automatically integrated into that monitoring. Management and operations can be done via Git.
So yeah.
And there are two different ways you can either push or pull.
And yeah, so the basic concept is that you store your configuration in Git, and then you have some magic process that's deploying from Git. And that's what we're doing for years, and we just do it slightly different in Kubernetes because everything is different in Kubernetes. Isn't that fun? So for the longest time, we have used push deployments. I mean, probably everyone knows these. You push your configuration to Git, and then some Git magic CI/CD job is running and is applying the configuration to your target system. It's nice, it works, but the main downside of it, and why we don't use it in Kubernetes as much, is it doesn't detect configuration drift. Let's say some engineer manually edited the cluster, and then your CD pipeline tries to apply a patch, and then for some reason it doesn't apply because it was manually edited before.
Also, your CI/CD pipelines need to have at least somewhat privileged access to your Kubernetes cluster, and you have to then handle secrets in your CI/CD system. Don't know if you really want to do that.
Yeah, kind of sucks.
So Kubernetes found a different way, the pull way. You have your GitOps operator deployed in your Kubernetes cluster, which does a Git pull on a regular basis, and then tries to apply the changes from inside the cluster. The GitOps operator knows the state of the cluster, and then also knows what kind of changes you have prepared.
Yeah, so main benefit of it, the operator runs inside of the cluster, so every time you manually edit the cluster, it knows you edited the cluster. So it can actually revert your manual changes and then reapply whatever is configured in Git. So it's kind of nice to keep a consistent state in Git. And our tool of choice for this, of course, it's Kubernetes. There's a million tools that do the same thing, but our primary tool of choice is Argo CD. It's really easy to use it, and probably the main benefit of it, and that's why I got started with it. It has a really nice looking UI. It's easy to sell to management. It's open source, so you don't have to get budget for it, but if you have to account for working hours going into setting up everything in Argo CD, it's nice when you can take this UI, take a screenshot of it, and show it to management, and they'll be like, wow, applications. So yeah, this is how it looks. Quite nice UI, pretty intuitive. The video loops. So you see the application is out of sync because someone manually edited the cluster, and then you can just press the sync button. In this demo, it's manually, but you press the sync button and it reapplies whatever is configured in Git. On production clusters, I usually set this sync to automated, so it's automatically reconciling everything. This brings us to the last topic about deployment-related shit. Sorry. You have to manage your secrets, right? You don't want to configure your Postgres admin password in clear text in your Git repository, right? We just said we store all of our configuration in Git, and leaking credentials through Git is pretty common, and we shouldn't do it. So there are some ways to manage secrets. There are two main ways to do it, and I want to focus on both of these. The first one is Git-crypt. It's probably the easiest one. It's based on PGP. You give it a list of files to encrypt, and then it just encrypts those files using PGP. There's no magic to it. And then the Argo CD operator then pulls the encrypted file, sees, oh, it's encrypted, let's decrypt it. I have a key, and then apply it. Nice. Problem, you can't do git diff. The whole file is encrypted. You change something in this file, your entire file changes. It looks horrible in pull requests. No way of knowing what is modified in the pull request. The better way of doing is at Mozilla SOPs. it's kind of similar. It can use PGP if you wanted to, but it also supports modern encryption like H or even Bitwarden, not Key Vault, HashiCorp Key Vault it's called.
Or your cloud provider's favorite way.
Yeah, like Azure Key Vault or AWS
Secrets Manager.
Secrets Manager, right? And it's nice because it allows you to do Git diffs. Because it's not the whole file that gets encrypted, but only the one single key that you specify to encrypt is encrypted. So when you diff the file, you see, oh, the encrypted value of that specific key changes. Game changer, helps in pull request reviews. Looks kind of like this. You can't read it, I'm sorry. The resolution isn't high enough. But here on the bottom part, you have your keys. That's where the symmetrical key is asymmetrical stored and encrypted stored. And then here you see the encrypted part. Only the value is encrypted, not the keys in front of it. Sorry that you can't really see it on the projector here.
Yeah, but what you can see is if someone changes something here, you will see in your Git diff that maybe your database password was rotated. And if you use gitcrypt, you just have a blob of encrypted text, and you won't know, did my database password change? Did my API keys for another application change? So way nicer, way easier to handle.
Awesome. I promise it's the last topic. We probably bored you enough with Kubernetes already. So last fun topic, at least for me, I love networking. I'm a networking guy. I really love networking. So how do we serve traffic to our application? I don't want to go into the details here, right? We can probably do like an entire day just talking about Kubernetes networking. So the absolute basics, you have a pod, the pod exposes a port, and then you have a service that directs traffic to that port. Looks kind of like this. You have your pod over here. It exposes a port, 8080 in this case. You give it a nice name, HTTP. And now you want to serve, you want to access it, right? So what you do is you deploy a service. The service knows about the pod based on the label. It has a label selector and it matches the labels of our pod. And then it also specifies our ports and how to map the ports. So if you connect to port 80 on our service, it will forward the traffic to port 8080 on the pod. And it automatically does all the load balancing magic. That's the main reason why you can't connect to a pod directly, but go through a service, because there's a whole lot of load balancing magic happening. And yeah, last step, you have another pod that wants to access network resources from the first pod, so it talks to the service. Service talks to the pod. Concept is pretty easy, right?
But you don't just want to have your pods talk to each other. You also want to serve traffic to your customers. So how do you do it? Either with a node port, or with a load balancer, or an ingress controller, or you simply don't serve any traffic to the customer. That way you also don't get complaints, because if there's nothing to serve, then nobody can complain. So for the easy mode, you have the node port. No real load balancing, no auto failover. You only have a very limited range of ports, and you also can't use any reserved ports. From your physical network, you go to more or less the node port, and you're done. Maybe not the best idea. Then you have the advanced mode. You have a load balancer. It's usually quite expensive. Most cloud providers bill you for each load balancer and for the and then again for the traffic. The certificate management is also limited by the cloud provider's capabilities. If your cloud provider doesn't support Let's Encrypt on the load balancer, then you also have to pay for their TLS certificates.
Same chart as before. You see the client wants to talk to our pod here on the right. And instead of talking directly to the service on a node port, it talks to a load balancer. This works with basically any major cloud provider load balancer implementation. It even works on Hetzner Cloud. So you basically talk to the load balancer, and then the load balancer forwards the traffic to a port on the machine, and then magic happens in the network. Works. But it's sometimes expensive, sometimes not the ideal choice.
Okay, but now you have the next big cloud application running in your Kubernetes cluster. You really have to scale up. What do? You work with an ingress controller. Most of the times, I would recommend using Ingress Nginx, which is, as far as I remember, completely open source. Or if you're really popular with your application, you also could use Envoy, which is really, really high performant. The applications that I have seen that use Envoy serve 6 to 7 figures of users. It has nice features like domain auto-discovery. So if you deploy a new service in your cluster, Nginx and Envoy will detect that service, and if configured correctly, will also give you automatically the right paths for your application. You can also do automated certificate deployments, and yeah, it's a bit expert in the configuration, but especially for bigger clusters, it's really the best way.
Yeah. Last one for the networking diagrams. You see, it's even more steps now. You've seen it's getting more and more complicated with each one, but it actually kind of gets easier to manage. So in this case, your client connects to the load balancer. Okay, we had that already, but now the load balancer connects to an ingress object in Kubernetes. The ingress is another service type thingy, and you see it here on the ingress YAML, and you select your service, the backend service that you want to connect to, and it's literally just name matching. And then you also specify the port number on your ingress that's forwarded to the service. I don't know, it's actually kind of straightforward. I don't know what to explain about that. It just scales pretty well. So that is 47 minutes of Kubernetes madness. To wrap it up, I summarized it. Take a Pi if you have one spare, install K3S on it, and have fun. Deploy some workload, experiment with it. It's actually quite fun, and don't be scared of Kubernetes. I know a lot of people are like, oh, Kubernetes, there's yet another layer, yet another problem that I have to work with. But it's not too complicated, even though it sounds really complicated. And there are a lot of terms. If you get started on a Kubernetes tutorials, there are tons of terms being thrown at you. Don't be intimidated by it. Learn it one step after another, and then congratulations, you have a working Kubernetes cluster. Yeah, that's it. Now we got some 12-ish minutes for Q&A. And yeah. One sec, we get a mic to you.
Test. Oh, no, okay. So what is, in your opinion, the best, let's say, storage class or implementation for storage regarding a multi or an easy multi-node cluster?
This is actually what I forgot to put on the slides, storage and storage classes. I personally prefer NFS for storage because you can have concurrent read-writes on NFS. But yeah, most of the times I would only use it if I really have multiple pods that require to work on the same storage. Otherwise, S3 is also really fine if you have your one pod that needs to read from its storage. And for separation, S3 is also pretty good. But yeah, with S3 you only have read-write once, so only one pod can connect to each S3 bucket. So you might need multiple ones.
Thank you very much.
Yeah, thanks for the talk. That's a question more in addition. Maybe you heard about Podman. It's open source by Red Hat, and it's pretty cool because it's able to play Kubernetes manifests. So it's a nice way of getting started when you want to have a single node deployment, but you want to be prepared for a next step on Kubernetes. So you can write the manifests, deploy them to a single node Podman node, and maybe reuse them later for a big scale deployment. Also nice for things you don't want to have in a Kubernetes cluster.
Yep. Nothing to add. I mean, you can try it. I mean, it works somehow.
All the way over there.
We go the row back and then you get it in the front, right?
Yeah, thank you for the talk. I have one small question regarding the ingress controller. I saw that you used the load balancer in front of the ingress. Can you tell me why?
So in theory, you could set up your... so you need to get your traffic to the Kubernetes nodes. And the way the ingress controllers typically work is you have a daemon set deployed that has one pod for the ingress controller, and in most cases it's Nginx ingress, which is just a fancy way of configuring Nginx reverse proxies. And you have this Nginx running on each of your nodes. And then the load balancer from your cloud provider will direct the traffic to, it just load balances traffic to every node. And then you have the ingress pods running on each of the nodes that then do the additional request handling.
Okay, perfect. Thank you.
Kind of a system orders, right?
Yes. And makes it easier to direct traffic. There are some other ways to do it. You can, in theory, do like node port bindings, but it's kind of janky. It doesn't really work if you want to use reserved ports like port 80, for example.
You showed us the different distributions of Kubernetes. How different are they? And if it runs on one of them, does it run on all of them? Or
I would say, again, it depends.
Yeah.
Migrating an application from Azure AKS to AWS EKS requires some smaller changes, but works. But for instance, shifting your application from bare metal Kubernetes to Red Hat OpenShift might require a bit more work than just deploying this the same code to that cluster. So always depends a bit on how your Kubernetes flavors are implemented.
and in your experience, if you run kind locally, is it compatible enough with the other ones?
So to add to your question a bit, so I said earlier in the talk that Kubernetes is basically just a set of a set of APIs, and different applications implement different parts of that API. In order to be allowed to call your application Kubernetes or something Kubernetes in the name of the application, you actually need to pass a set of conformance tests by the CNCF, by the Cloud Native Computing Foundation. So when you go to a cloud provider and you see they have like Kubernetes in the name, they usually have somewhere on the page a badge that says CNCF certified Kubernetes, and that means it meets the standard requirements for a Kubernetes application. And you can certainly deploy something in kind, and if it interacts with the API, you can expect it to behave similar enough on another Kubernetes distribution. But the devil is in the details. If you really use some niche features of, let's say, AKS. AKS has some pretty niche features about how to do networking and stuff, and you extensively use those features, and then you want to migrate to another Kubernetes, you certainly run into problems. It's similar if you use EKS, the Amazon version of it, and rely on how storage is configured and storage classes are set up in EKS, and then you migrate to, let's say, kind. You don't have storage classes in a similar way in kind as you have it in EKS, so you might run into problems there. But usually, as long as something is Kubernetes certified, it should work. I mean, there are some kinks to iron out, but most of the time it works. I never experienced like major incompatibility between cloud providers.
You might lose some sugar on the top that, for instance, OpenShift provides in comparison to bare metal Kubernetes. But yeah, your base of your application should be transportable between the different flavors.
Thank you.
All right. Sorry, I haven't forgotten about you. You get your microphone. Promise.
So about Docker, everyone is saying Docker dies. What you would prefer as the next dominating container runtime for the future?
So yeah, Docker is good that you mention it. Thank you for the question. I think that's a nice one to talk more about. Everyone is aware that Docker right now is kind of going evil with their policies and license agreements and stuff. But Docker itself is not everything. Docker is like one specific implementation of a container. You can use the same containers and the same images and run them in CRIO or containerd. And since Kubernetes 1.18 or 1.19, the Docker support is entirely out. So
it's removed now.
Yeah, it's completely removed. If you start a container in Kubernetes, it's not actually running Docker anymore. It's running by default containerd.
Yeah, I think it was in 1.18 where they removed the Docker support.
Yeah, and it's pretty much a drop-in replacement. There's no need to rely on Docker, because the specification for containers is universally agreed on.
All right, thank you, sir. Who's the next?
Pass the microphone forward.
As promised.
Thank you. I have a comment about using the Podman Kubernetes manifest support, because right now it does not support
No, it's on.
You just need to put it closer.
A little bit closer.
Yeah. In my experience, Podman does not support a lot of the stateful details of the Kubernetes manifest, so you don't get stuff like replica sets, deployments, storage classes in any meaningful ways, and that means you make a lot of hacks to make things work that don't make sense on actual Kubernetes, and that is a problem in my opinion.
Thank you. Right next to you.
Thank you. I have a question. So let's assume we have multiple instances, backend instances of some application, and how would we store cache for it?
You mean caching in Kubernetes?
Yeah.
I mean, that's pretty much not a Kubernetes question, right? That's more of an how to write your application question. What you can do is you deploy an Redis cache. Was it Redis? Yeah, Redis. Yeah. I always mix Redis and RabbitMQ. Sorry. You use Redis as a cache. Deploy your Redis cache in Kubernetes, and then your application is caching data in Redis. That usually works quite well. But it's not really about Kubernetes infrastructure itself. It's more about how you structure your application. Maybe you want to do some in-memory caching inside of your application for having it even faster. But that's really a decision that should be made at software architecture time.
Okay, thank you.
Okay, I think then also we're,
Pretty much on time.
yeah.
So,
So a bit of shameless self-plugging. My colleague has done great talks about observability and site reliability engineering.
and we've also done a shit-talking talk about Kubernetes. It's not worth watching, to be honest. It's like 15 minutes. We had to cut it short. We had to stop the recording because of some NDA shit.
But yeah, there we talked about the good, the bad, and the really ugly parts of Kubernetes. If we haven't scared you away yet, that talk will definitely scare you away from it. But then, thanks for being here. Thanks for listening to us, and have a nice day at FrostCon.